So in previous class we learned the different types of cells and also the circuit symbols and how a simple circuit is drawn, right? Yes, Sahil. Previous lesson, which heat and energy you're talking about? Okay, what happened in that lesson? So, questions related to exercise B and C are not given to you all. Okay, but the lesson is taught, right? The whole lesson is taught to you all. Then what is done in that lesson? Only exercise, only part A and D is taught to you all. Okay, so B and C is not taught to you. Okay, fine. Are question answers given to you all for that lesson? Exercise A and D is given. Solutions for exercise A and D is given. Okay, so B and C has to be given and taught also. Fine, I'll do it later. Okay. Okay. Now, presently we'll continue with current electricity lesson where we finished with exercise A where we learned the different types of cells, the sources of DC current and the circuit symbols and the circuits, right? Now today we will see what is potential difference and resistance. You all can see the screen, right? The slides. Okay. So today we will first see how do electrons flow or why do these electrons flow and in which direction do they flow. Now, as we can see, now if I take two metals or two charged particles. Now what are charged particles or a charged body? Whenever a body has got number of electrons or number of protons greater or when number of protons and number of electrons are not equal to each other in the given object, then we say that the body is charged. Now that body can be positively charged or negatively charged depending on the number of protons and electrons. Okay, so if in a body or in a conductor the number of protons are more compared to number of electrons, then it is called as positively charged body. If the number of electrons are more compared to number of protons, then that conductor or an object is called as negatively charged. And third condition is if the number of protons and electrons are equal, then it is it does not have any charge on it, so it is not charged. Yes, neutral, what you can say. Okay, so now we will see if we have two bodies, one is charged, the other is uncharged. How do electrons flow? Now, as you can see in figure 9.8, right? Sorry, 9.18, the first figure. We can see here we have a positively charged conductor, right? A, and we have an uncharged conductor B. Now, positively charged conductor has protons more, and uncharged conductor has number of electrons and protons equal. So here what happens, if I compare both the conductors, the number of electrons, right? The number of electrons in the uncharged body will get attracted towards the positively charged, they will get attracted towards the positively charged, positive charge, that is protons. So what happens is the electrons, that is, we always know that opposite signs attract each other, right? And in the atom we know that only electrons are free to move. That is why electrons, since they are negatively charged, they start moving towards the positively charged conductor, that is negative, they start moving towards the opposite charge, right? So flow of electrons between an positively charged conductor and an uncharged conductor, as we can see, it always moves from uncharged conductor to charged, positively charged conductor, right? So next condition, in second condition we can see we have a negatively charged conductor and an uncharged conductor. Now here what happens is in conductor A, number of electrons are more and compared to protons. So here what happens is these extra electrons which are there, they start moving towards the uncharged conductor. So here the direction of flow of electrons will be from negatively charged conductor to uncharged conductor. Getting it? And if I connect, or if I have two conductors, one is negatively charged, the other is positively charged. If these two conductors are connected, then electrons will move from negatively charged conductor to positively charged conductor. So this is how the electrons flow. This gives us the direction of flow of electrons when we have charged, uncharged, or the charged or uncharged conductors connected with the wire. Hope you all have understood this. Okay. So now we will see, we just now saw that how electrons are flowing, right? The direction of flow of electrons. Now we will see why do they flow in that particular direction only. Now here, as we can see in figure 9.21, now if I have, say, a ball, okay, if I have a ball which I throw in upward direction, what happens to that ball? It will come down, right? Why does it come down? Because when we have a ball which is on ground floor, it has got low gravitational potential energy, and whenever we keep a object at some height, or say at the top of a building, there the energy possessed by the object will be high. That is, it will have high gravitational potential energy. That is why whenever we throw, say, any object from an height, it always moves downwards. It doesn't move in upward direction. Why? Because energy always moves from high concentration to low concentration. Okay. So one more example. As we can see in figure 9.22, we have two containers filled with a liquid, right? And the two containers are connected with a pipeline. Okay, so as we can see in container A, the level or the amount of liquid is more compared to amount of liquid in B. So what happens is when we connect these two beakers, the water starts flowing from container A to container B. Why? Because the concentration of the liquid in A is more compared to concentration in liquid in container B. So that shows that always there will be motion from high concentration to low concentration. It may be related to energy, pressure, or it can be even temperature. So one more example where we can show that it always moves from higher to lower level is, if I have, say we have kept a vessel, okay, on a gas, and we have on it. Now after say 5 minutes, the vessel will get heated up, its temperature increases, right? Now in that vessel, if I place a spoon into it, what happens after 2-3 minutes? We can see that the spoon also starts getting heated up. That is, the temperature of the spoon goes on increasing. Why? Yes, the spoon gets heated up. Why? Because the heat energy or the temperature of the container is more compared to the spoon when we immediately keep the spoon. So, what happens is the heat energy gets transferred from the vessel to the spoon, right? So, what is happening over here? High amount of heat is getting transferred to the spoon which is at lower temperatures, right? So here also we can see that the flow of heat is from high level to low level. So in general, in the universe, anything it may be, always the direction of flow is always from higher level to lower level. So this principle is used in flow of electrons. Okay, that is why we saw what is the direction in the previous thing. So now if I connect a positively charged body and a negatively charged body, what happens is, in the positively charged body, the number of protons are more, and in a negatively charged body, number of electrons are more. So now we know that electrons will move, protons cannot move. So what happens is, electrons, that is from negatively charged body where the concentration of electrons is more, they start moving from the negatively charged body to positively charged body, that is from higher level to low level, right? But the flow of current is always opposite to the flow of electrons. So we know that electrons always flow from negative terminal to positive terminal. But current flows always in the opposite direction, that is from positive terminal to negative terminal. Did you all get this? Okay. So next we will see what is potential difference. Now this potential difference is also called as voltage. Now, as we saw here, that always current flows from higher concentration to lower concentration. Now, what if the concentration on both the bodies is same? If the concentration on both the bodies is same, then what will happen? There will be no flow of charges, right? Because both are at same concentration, right? So that is why there should always be some difference in the concentration at the two terminals. So this difference in the concentration in current electricity is called as potential difference. So here concentration is called as potential, so or voltage. So always between the two terminals. Now in an electric circuit we have positive terminal and negative terminal. So at the positive and negative terminal there has to be difference of potential between them, that is difference of concentration of electrons between the two terminals. Only then the flow of electrons takes place. So that difference is called as potential difference. It is also called as voltage, right? So potential difference is a scalar quantity, that is it does not depend on direction. So potential difference is denoted by V and is given by work done upon charge, where W is the work done and Q is the charge. And potential difference is measured in volts. Understood this? Okay. Now we saw what is potential difference. That is, it is the difference in potential levels at the two terminals, right? So whenever there is difference in the potentials between the two terminals, the flow of electrons takes place, and once the electron starts flowing, current also flows, right? Okay, next we will see what is resistance. Okay, we will see what is electrical resistance. Now, as you can see in this figure on the screen, we have a metal wire. Now, inside the wire, what do we have? Wire is made up of molecules, and molecules have electrons and protons. Now, you can see the red ones in the left side are the electrons, and with the positive sign they are protons. Now since electrons and protons are present in the wire, what happens is, if there is no potential difference, then what happens, the electrons will start moving in random motion. They will not have any specific motion direction to move in. But if the same conductor is connected across a cell, that is which has got a positive and negative terminal, that is it, if it has got a potential difference. Now if there is potential difference, what happens, then electrons will start moving from higher concentration to lower concentration. Now here negative terminal, what we can see here, this minus sign. So this negative terminal implies that number of electrons are more here, and positive terminal implies that number of protons are more here. So what happens, now always as we know, the flow is always from high concentration to low concentration. So if I compare minus and plus, the number of electrons at negative terminal are more compared to positive terminal. So what happens, the electrons will start moving from negative terminal, that is from this side towards the right, then on top into the metal wire, and these electrons, as you can see, will start moving towards the positive terminal. So this gives us how the electrons flow. But whenever these electrons are flowing, there is some force which will always try to oppose it. That is, it will always try that electrons will not flow further. That is, it will try to decrease the speed of electrons. That force which opposes the flow of electrons, which will always try to decrease the speed of electrons, is called as electrical resistance or resistance. Getting it? Right? So, resistance is what? It is the obstruction offered by the conductor to the flow of electrons. Okay. So, resistance is denoted by R, and it is given by potential difference, that is V, divided by flow of current in the wire. So we have formula R is equal to V upon I, or if I can rewrite it as V is equal to I into R, and unit for resistance is ohms, unit for voltage is volts, and that of current is ampere. So did you all understand what is resistance? Yes, any doubts till now? Okay. Next, moving on to what are the factors which affect this resistance? Now, the resistance of any conductor depends upon four main factors. The first factor on which the resistance of a conductor depends is the material of the wire. Now, as we know, we have different types of materials, like we have copper, aluminium, steel, wood, plastic, right? So, in this, we know that few will allow electricity to flow through them and few will not allow. Now, uh, when we say copper or aluminium, these metals will allow electricity to flow through them. So we can say that these materials have low resistance. That is the opposition force. That is the opposition for the electrons, flow of electrons is less. But if I consider wood or plastic, now if I connect a battery to wood or plastic, what happens? We can see that there is no flow of current in it. Why? Because the resistance of those materials is high. That is, the force applied for the opposition of flow of current is very high, due to which they won't allow the current to flow through it. So they have high resistance. So the materials having high resistance do not allow current to flow, and materials having low resistance allow current to flow. So the first factor is material of wire. The second factor is length of wire. Now, if the length of the wire goes on increasing, then if the length of the wire goes on increasing, then the resistance on the wire will also go on increasing. That is, what happens is, as the length increases, the resistance goes on increasing. So, shorter wire will have less resistance, that is, flow of current will be more in such. And if the length of the wire is more, the flow of current will be less. The third one is cross section of the wire. That is the thickness of the wire. Now, as you can see, you see your mobile charger and the mobile charger wire and the wire of the refrigerator. You can see the thicknesses are different, right? You can see that the refrigerator wire is thick and that of the mobile charger is thin. So why it is thin? Because the mobile requires very less amount of current, but the refrigerator requires high amount of current. So we can say that if the thickness is more, then resistance will be less. And if thickness is less, resistance will be more. That is why thinner wire will have less current flowing in it. So we can say that thickness is nothing but area of cross section. So if area of the cross section increases, that is thickness of the wire increases, then the resistance will be less. And the last one is the temperature of wire. Now, if the temperature of the wire goes on increasing, then the resistance of the material will also go on increasing. So, temperature and resistance of a wire are directly proportional. Both will increase together. So, these were the factors which affect the resistance of conductor. Any doubt till here? Have you all understood this? Okay. Then the last concept in this lesson we will see, that is efficient use of energy. What do we mean by efficient use of energy? Means we have to use the energy efficiently. That is, we should never waste the energy what we have. For example, if in our house we have, if we are sitting in some room, we use fan, tube light, right? Once we are out of the room, what we have to do? We should off the fans and lights whenever we are not using. If we don't off and if we keep it on, what happens? The energy is wasted. So we should not do that. So we have to always use the electricity or energy properly. Yes. So we will see how can we use these energies properly. There are main two processes where we have to use the energy properly. One is the cost of energy. We have to use the energy properly to reduce the cost of energy. And secondly, we have to see that no harmful gases are emitted. That is, no greenhouse gases are emitted. Now, how can we do the first one? The first example where we can use energy sufficiently. Now, whenever the house has been built, we have to see that wherever there is sun rays coming in the direction of the sun rays, we should always have the windows or doors. So, what happens is whenever we have the doors and windows in the direction of sunlight in the daytime, or till evening, we don't have to use artificial lighting. That is, we don't have to use our tube lights or bulbs. What happens if I use, if we build a building in the, if we have windows and doors in the opposite direction of sunrise or in the in the opposite direction, then there will be darkness in our house or in the room in the daytime also. So what we'll have to do in the daytime also, we'll have to use the bulbs or tube lights. So there what is happening? Unnecessary use of electricity is happening. So due to this what happens? Our electricity bill will also be more. We'll have to spend more. So one of the examples where we can use efficiently is building the doors and windows in the proper direction. Secondly, we have different types of bulbs, right? Nowadays, we have LED bulbs, then we have tube lights, then we have CFL bulbs. Now, when we have CFL bulbs, the you normal bulbs which are there of 100-watt bulbs, there what happens is they use lot of energy, but the brightness they give is less. So that is why nowadays we have LED bulbs, right? Where the amount of brightness given by them is more and it consumes less energy. So, when it is consume less energy, the electricity bill will also be less. So this is one of the this is second example where we can use the energy efficiently. One more we can see is vehicles. Now, when we have two-wheelers or four-wheelers, where we use fuels, right? Where we use diesel or petrol. Now, the vehicles which are heavy. Now, if you consider example of a vehicle, Activa only. Now, if you see an Activa which was say 5 years back and the recent model, we can see that the weight of the recent model is light, weight is less compared to the model which was 5 years back, right? So what is happening here? As the weight of the vehicle goes on decreasing, it gives us it uses fuel more efficiently. That is why we always go for lighter vehicles. There the engine uses less fuel and mileage will also be more. So this is one more example where we can use energy efficiently. Getting this? Even the gadgets which we use or electronic items what we use. For example, refrigerators or any electronic items. Nowadays in your ads you can see no they tell 5 star, 4 star, right? They give you the ratings to these electronic items, right? Means what they do is they tell us how much efficient it is. Now when we have refrigerators, ovens, stoves, these appliances, they come with star ratings like 4 star, 5 star. So more the stars it has got, more is its efficiency. That is, it uses less energy and gives us more of output. So this is one more method. While buying appliances, we should always see that the star rating is more. So these are few general examples where we can use energy efficiently. So here it can be any energy. It can be electrical energy, heat energy, light energy, right? So any of this energy. So have you all understood this? Any doubts in this lesson?